How do these workers achieve the impossible? Pushing the limits of human ingenuity, they perform feats that seem straight out of a science fiction movie. What you're about to discover will literally redefine your vision of the world of work and innovation. Stay tuned until the end, because what these workers do will be engraved in your memory. Meet the walking excavator, an engineering marvel designed to tackle the most challenging jobs in construction. Unlike conventional excavators limited by their tracks or wheels, this remarkable machine features a high-tech chassis and specialized boom that allow it to navigate with unprecedented versatility. The secret lies in its extraordinary mobility system. Each leg can move independently, enabling the excavator to maintain stability even on the steepest slopes where ordinary machines would tumble. These mechanical marvels can delicately position themselves on rocky ledges, traverse muddy swamps, or even wade through shallow streams without losing their operational efficiency. Watch as operators guide these mechanical spiders across terrain that would defeat any conventional construction vehicle, demonstrating perfect balance and precision that seems almost impossible for such massive machines. The walking excavator represents the pinnacle of adaptive engineering, providing solutions for construction projects in mountainous regions, wetlands, and other challenging environments that would otherwise require expensive alternative methods or remain completely inaccessible. With their ability to rotate, climb, and precisely position themselves, these machines have revolutionized infrastructure development in rugged landscapes around the world. Whether installing pipelines across mountainous territory or conducting delicate environmental restoration work along steep riverbanks, the walking excavator accomplishes tasks that once seemed impossible. This technological breakthrough has not only expanded construction capabilities, but also reduced environmental impact by minimizing the need for temporary access roads and allowing more precise work in sensitive ecological areas. In the world of modern construction, efficiency often comes from unexpected innovations. Dome-shaped structures have become increasingly popular for storing bulk materials, offering exceptional strength-to-weight ratios and maximum interior space. What makes these domes truly remarkable, however, is the revolutionary construction method that allows them to be assembled in a fraction of the time required for traditional buildings. The process begins with something that looks more like a giant balloon than a construction site, a specially designed inflatable form that creates the perfect dome shape when filled with air. This massive air-filled structure serves as both the initial framework and the interior formwork for what will become a permanent, robust storage facility. Once the dome is fully inflated and secured, skilled workers line the interior with layers of reinforced concrete, systematically applying the material to create a solid, durable structure. This ingenious approach eliminates the need for expensive exterior scaffolding and complex framework that traditional construction methods would require. The pneumatic form ensures perfect curvature throughout the dome, creating the ideal structural shape that naturally distributes forces and maximizes strength. When the concrete cures completely, the result is a monolithic structure with exceptional durability, weather resistance, and storage capacity, all achieved through a process that dramatically reduces construction time and labor costs. These pneumatic-formed concrete domes have revolutionized bulk storage solutions across industries, from agricultural products and raw materials to salt storage for municipal road departments. Road construction has traditionally been one of the most disruptive infrastructure activities, causing traffic delays and frustrated commuters. Until recently, there seemed to be no escape from the inevitable congestion caused by roadwork. But innovative engineering has finally provided an elegant solution. Enter the road printer, a machine that's transforming how we approach pavement construction with its remarkable speed and precision. Just as desktop printers revolutionized document production, these massive paving machines are changing our roadways by laying bricks in perfect patterns at astonishing speeds. The technology works by carefully arranging individual pavers into the desired pattern before placing them precisely onto the prepared road base in one continuous, fluid motion. Operators simply feed the machine with pavers, and the road printer does the rest, creating perfectly aligned sections of roadway that would take teams of workers days to complete by hand. What makes this technology truly revolutionary is its pace. The machine can lay thousands of square feet of paving in a single day, reducing project timelines from weeks to mere days. The precision of machine-laid pavement also ensures greater uniformity and potentially longer lifespan for the finished road, as human error in placement and alignment is eliminated. Beyond speed and quality, the road printer significantly reduces labor costs while protecting workers from the physical strain of traditional paving methods, which often lead to repetitive stress injuries. As cities around the world face increasing pressure to maintain and expand infrastructure while minimizing disruption to daily life, the road printer represents a perfect example of how technological innovation can solve seemingly intractable urban problems. Traffic congestion from construction zones has long been considered an unavoidable inconvenience of modern life. But what if vehicles could continue flowing while essential roadwork takes place directly beneath them? This is exactly what portable road bridges accomplish, an ingenious solution that literally elevates traffic above construction zones, allowing simultaneous repair work and vehicle movement. These modular bridges can be rapidly deployed anywhere road maintenance is planned, creating a temporary elevated roadway that carries vehicles safely over the work area. The system consists of sturdy, prefabricated sections that can be transported to any location and assembled quickly by a small crew using standard construction equipment. Once in place, drivers simply follow a gentle ramp onto the elevated platform, passing smoothly over the construction zone before returning to the normal road surface on the other side. Beneath the bridge, construction crews can work efficiently and safely, completely separated from traffic, allowing them to focus entirely on repairs without the constant danger of passing vehicles. This revolutionary approach eliminates the need for lane closures, detours, or reduced speeds that typically cause bottlenecks and traffic jams around construction zones. For urban areas where traffic disruption creates significant economic impact, these portable bridges offer a compelling alternative that maintains mobility while allowing essential infrastructure maintenance. The versatility of these systems means they can be implemented on roads of various widths and for projects of different durations, providing traffic engineers with a flexible tool for minimizing the impact of necessary roadwork. In the world of construction and demolition, sometimes the most effective approaches don't involve complex technology or expensive machinery. When facing the challenge of bringing down a massive structure, most contractors might immediately turn to heavy equipment or explosives, but not the innovative workers featured in our next segment. Armed with nothing more than simple sledgehammers and an ingenious understanding of structural mechanics, these resourceful demolition experts demonstrate that human ingenuity often trumps technological complexity. The key to their approach lies in identifying the critical support points within the structure and applying focused force precisely where it will have the greatest impact. By strategically weakening key structural elements in a carefully planned sequence, they create a controlled collapse that brings the entire building down with remarkable efficiency. What makes this method truly impressive is not just its effectiveness, but the minimal resources required. No fuel-hungry machinery, no expensive explosives, just human power applied with expert precision. The demolition, when executed according to their careful planning, transforms into a spectacular display of physics in action as gravity does the majority of the heavy lifting. This approach also offers significant environmental benefits, producing less dust, debris, and pollution than conventional demolition methods that rely on heavy machinery or explosive force. For communities with limited resources or in locations where access to specialized equipment is restricted, these techniques provide a viable alternative that empowers local workers to handle large demolition projects. The success of this method serves as a powerful reminder that sometimes the most effective solutions come not from technological advancement, but from deeply understanding fundamental principles and applying them creatively. Conventional wisdom in construction has always maintained that the thicker a concrete slab, the stronger and more reliable it will be. However, innovative engineers have challenged this assumption by developing a groundbreaking method that creates ultra-thin concrete structures with strength comparable to much thicker traditional slabs. This revolutionary approach begins with the creation of a specialized reinforcement framework that provides the foundational support for the entire structure. Once the reinforcement is in place, workers stretch a specially designed fabric over the framework, creating a flexible yet sturdy base for the concrete application. The magic happens when concrete is poured onto this fabric system. The material flows into and through the specialized textile, creating a completely integrated structure with exceptional strength characteristics. What makes this technology truly remarkable is the dramatic reduction in materials required. These thin shell structures use significantly less concrete while maintaining structural integrity equal to conventional methods. Beyond material efficiency, this approach offers unprecedented design flexibility, allowing architects and engineers to create flowing, organic forms that would be extremely difficult or impossible to achieve using traditional concrete forming techniques. The lightweight nature of these structures also reduces the load on foundations and supporting elements, potentially decreasing overall construction costs and opening new possibilities for building on less stable ground. Environmental benefits abound as well. The reduction in concrete usage means lower carbon emissions associated with cement production, one of the most energy-intensive aspects of construction. As the construction industry faces increasing pressure to reduce its environmental footprint while maintaining safety and durability, fabric-formed concrete represents one of the most promising innovations in sustainable building technology. When faced with the challenge of relocating an entire garage structure, conventional wisdom might suggest dismantling and rebuilding or employing expensive heavy equipment. But in an extraordinary display of human coordination and collective strength, a team of precisely 92 workers demonstrated that sometimes the most effective solution is also the most direct. Each person, strategically positioned around the perimeter of the substantial building, worked in perfect synchronization to physically lift and move the entire structure over a distance of 300 meters. What makes this feat particularly impressive is not just the successful relocation, but the perfect preservation of the building's structural integrity throughout the entire process. The key to their success lay in careful planning and extraordinary team coordination. Each participant had to apply exactly the right amount of force at precisely the right moment to prevent any twisting or structural damage. This human-powered approach eliminated the need for cranes, specialized transport vehicles, or helicopter assistance that would typically be considered necessary for such a substantial moving operation. Beyond the impressive physical accomplishment, this method offered significant cost savings and demonstrated remarkable resource efficiency in a world that often defaults to fossil fuel-powered solutions. The successful relocation stands as testimony to what can be accomplished through collaborative human effort when guided by thoughtful planning and executed with disciplined coordination. For communities with limited access to specialized equipment or in situations where mechanical solutions would be prohibitively expensive, this approach offers a viable alternative that capitalizes on available human resources. This extraordinary moving operation reminds us that sometimes the most innovative solutions don't require cutting-edge technology, just human ingenuity, careful planning, and the combined strength of a well-coordinated team. The hospitality industry is witnessing a revolution in construction methodology that promises to transform how hotels are built, particularly in remote or environmentally sensitive locations. A team of highly skilled builders has developed an innovative approach to hotel construction that prioritizes both speed and environmental harmony, creating comfortable accommodations that blend seamlessly with their natural surroundings. The secret to their remarkable efficiency lies in the use of specialized prefabricated modules, each containing complete living spaces that can be rapidly assembled on-site into fully functional hotel structures. These purpose-built units are manufactured under controlled conditions, ensuring exceptional quality and consistency, while dramatically reducing the time required for on-site construction work. What makes these builders truly exceptional is their ability to adapt to challenging environments. They can establish their modular systems on remote mountainsides, within dense forests, or along pristine coastlines with minimal disruption to the surrounding ecosystem. The resulting eco-hotels provide guests with a unique opportunity to immerse themselves in natural settings while enjoying comfortable accommodations that have been thoughtfully designed to minimize environmental impact. Each module incorporates sustainable technologies, including energy-efficient systems, water conservation features, and materials selected specifically for their low environmental footprint throughout their life cycle. The rapid assembly process means that hotels can be constructed during optimal weather windows or between tourist seasons, minimizing both construction challenges and business disruption. For regions seeking to develop tourism infrastructure without the lengthy construction periods and heavy environmental impact of conventional building methods, this modular approach offers an ideal solution. These innovative eco-hotels represent the perfect marriage of construction efficiency, environmental responsibility, and exceptional guest experience, a combination that is increasingly setting the standard for sustainable hospitality development around the world. Concrete has long been viewed as a purely utilitarian material, functional, durable, but rarely beautiful in its own right. But in the hands of visionary artisans, this humble mixture of cement, sand, and water is being transformed into stunning architectural features that challenge our perceptions of what concrete can be. The secret to creating these remarkable concrete ceilings lies in innovative forming techniques that allow designers to embed complex patterns and textures directly into the material during casting. Skilled craftspeople begin by creating intricate molds with geometric patterns, flowing curves, or nature-inspired textures that will shape the concrete's final appearance. When the carefully formulated concrete mixture is poured into these specialized molds, every detail is captured with perfect fidelity, preserving even the most delicate patterns in durable, permanent form. After curing, these concrete elements reveal stunning visual and tactile qualities that completely transform the spaces they inhabit, creating environments that engage the senses in unexpected ways. What's particularly remarkable about these artistic concrete applications is how they unite structural necessity with aesthetic beauty, allowing essential building elements to become focal points rather than features to be concealed. Architects and designers are increasingly embracing these techniques to create signature ceilings that define the character of spaces ranging from luxury homes to public buildings, museums, and corporate headquarters. The versatility of concrete as an artistic medium allows for limitless expression, from subtle textures that create interesting plays of light and shadow to bold sculptural forms that make dramatic architectural statements. As our appreciation for materiality in architecture continues to evolve, these concrete artworks demonstrate that even the most common construction material can be elevated to extraordinary beauty through creative vision and skilled execution. Malaysian engineers have pioneered an innovative construction technique that challenges traditional concrete usage while maintaining structural integrity. This groundbreaking approach incorporates specially designed spherical voids within concrete floor slabs, dramatically reducing material consumption without compromising strength. The system works by precisely positioning hollow plastic spheres within the concrete form before pouring, creating a grid of internal voids in the non-structural portions of the slab. These strategically placed spheres displace concrete exactly where it contributes least to structural performance, maintaining material only in areas critical for load-bearing capacity. The result is a revolutionary biaxial slab system that significantly reduces the dead load of buildings, the permanent static weight that structural elements must continuously support. With lighter floor systems throughout a multi-story building, engineers can design more slender columns and foundations, creating a cascading effect of material savings throughout the entire structure. Beyond material efficiency, this approach offers substantial environmental benefits by reducing cement usage, a manufacturing process responsible for approximately 8% of global carbon dioxide emissions. The economic advantages are equally impressive, with projects reporting concrete savings between 25 to 35% compared to solid slabs of equivalent strength, translating to significant cost reductions. For tall buildings where the cumulative weight of floor systems creates enormous structural demands, this void form technology has proven particularly valuable in enabling more elegant and efficient designs. As the construction industry increasingly focuses on sustainability and resource efficiency, this Malaysian innovation exemplifies how rethinking fundamental assumptions about building materials can lead to remarkable improvements in both performance and environmental impact. These extraordinary workers reveal what's possible when human ingenuity meets challenging problems. Their innovative techniques, From simple, resourceful approaches to cutting-edge technological solutions are transforming construction worldwide. By prioritizing efficiency and sustainability, they're building a better future while inspiring us all to think differently. Subscribe for more amazing examples of workers who truly surpass everything you've ever seen.